we will try to price a put option by using the binomial model, and actually every input value is the same as that for the previous example in which we use the binomial model to price the call option. So everything is the same, stays the same. But now the example will be about a put option. So as an options trader at the CBOE, you are tasked with pricing a European put option on Quake Games Incorporated. The strike price is $75 and there are 6 months until expiration. Quake Games common stock doesn't pay dividends and is currently trading at $57. Based on your models, the future stock price is predicted to be either $92 or $40 at the end of the next 6-month period. The effective annual risk-free rate is 4%. Estimate the price of the put. How much of a share of the stock do you need to buy or short, and how much do you need to borrow or lend at the risk-free rate to replicate the put through a synthetic portfolio, and check whether your synthetic portfolio replicating the put will have the same payoffs as those of the put at expiration. Actually, without delving into solution, we can share that, we can actually claim that the fraction of a share of the stock you need to buy in this case of a put option, or the delta value or the hedge ratio, should be a negative value in that case, because as a put option holder you are shorting the stock, and this is important. And also we are talking about borrowing or lending. For the case of the put option, you are lending at the risk-free rate. We will see. And that's why the B0 value in this example will have a positive value. We will see. So as we did before, now create these two diagrams. The current price of the stock is $57 again, and at time 1, within 6 months from now, the price of the stock can increase to $92, or in the second scenario, the lower boundary case, the stock price can drop to $40. And create the same for the put option. Remember, this is what we are after, the price of the put option. Strike price is $75. So at time 1, if the stock price is $92, the put option will not be exercised, because you won't be buying the stock in the market at $92 and sell it for 75. Remember, we are taking the maximum between these two values, x strike price minus S1, plus or 0. This is a negative value, so P1 plus will be 0 in that case, and in this scenario, actually, evidently, you won't be exercising the put option. But if the stock price falls to $40, you can buy the stock in the market at $40 and sell it at $75 as a put option holder. You have this right to sell it at the exercise price at expiration. So in that case, at time 1, again, we are taking the maximum between these two values, x minus S1 minus, here, the payoff or the price of the put at time 1 will be $35 under the second scenario. So next, we should convert the effective annual rate to representative periodic rate. 1 plus 0.04 to the power of 1 should be equal to 1 plus r semi-annual to the power of 2. Remember, there are 2 6-month periods within a single year, so that's why 1 plus effective annual rate to the power of 1. The compounding in a single year should be equal to 1 plus r semi-annual, or r 6-month to the power of 2. And when you solve for r semi-annual should be, we are just leaving this term alone so that we can calculate it. So 1.04 to the power of 1 over 2 minus 1 should be equal to 0.0198. Then plugging the numbers into the following equations will yield the following. So H0, the hedge ratio, or the delta. Remember, the change in the payoffs in the put option divided by the change in the stock price. So these all of these values were calculated on the previous slide. Just plug in them and you will get minus 0.6731. Note that this time this hedge ratio or delta is negative. You are shorting the stock. And then calculate the amount you need to lend. Here we have this formula. We know all of these values. H0 was already calculated in the previous step. Just plug this value into this equation. So B0 should be $60.721. And note that this time it is positive, meaning that you are lending rather than borrowing in this case. Now we can calculate the value of the replicating portfolio, which should be equal to the price of the put. So P0, price of the put, should be equal to value of the replicating portfolio at time 0 or now should be equal to, remember, H0 multiplied by S0, the current stock price, plus P0. All of these values were already calculated. S0 was already given. Just plug the numbers into the equation. So the P0 value or V0 value will be $22,353. So we create a synthetic put by shorting 0.6731 shares of the stock and lending $22,353 at the risk-free rate. Now I will check whether the synthetic portfolio replicating the put will have the same payoffs as those of the put at expiration. Remember, for the upper boundary case, S1 plus case, the stock price is 92 and the payoff for the put will be zero because the put with a strike price of $75 will not be exercised. So you won't be buying the stock at 92 in the market and sell it for $75. So the put will be worthless in that case. And V1, the value of the replicating portfolio, should also be equal to zero in that case if it really replicates the put as is claimed. So V1 then should be equal to H0 multiplied by S1 plus B1. You know H0 already, S1 was already given $92, and remember B0 should be calculated B1 should be calculated by multiplying B0 multiplied by the future value factor, which is 1 plus R. Because remember, we are trying to calculate the value of the replicating portfolio at time 1, not 0. That's why we need B1 rather than B0. So that's why B0 multiplied by 1 plus R. R was already given. So this is equal to 0. Actually, V1 has a value of minus $0.00192, which is very close to 0. The difference stems from the rounding. If you were to use exact values of H0 and B0 or B1 more precisely, as well as of the risk-free rate, you will get V1 equal to 0. For the lower boundary case, remember S1 minus is $40 and P1 is 35 because now you can now buy the stock at $40 in the market and sell it for $75. So the payoff will be $35. So the put with the strike price of 75 will be exercised. And in that case, V1, the value of the replicating portfolio, should also be equal to $35 if it really replicates the put as is claimed. So V1 equal to H0 multiplied by S1 plus B1. Again, the same formula we used for the upper boundary scenario. So H0 was already calculated, multiplied by S1 minus $40. B1 will be B0 multiplied by the future value factor, so $35. Again, here V1 has a value of $34.999, which is very close to 35. These small differences stem from the rounding.